In 14.2, we're going to deal with something called a complex fraction. A complex fraction is basically a fraction that has a fraction inside its numerator and denominator. Let me show you what that looks like. This is a complex fraction because there is a fraction in the numerator and a fraction in the denominator. A complex fraction may have one fraction or multiple fractions inside the numerator and denominator. If there is at least one of them, your job will be to clear the complex fraction in order to simplify the problems. So all of these are going to be expressions, and they're going to be things that you're going to have to reduce. So what you are going to do in a lot of these problems is you are going to clear them by multiplying by something called the LCD. You learned what this was probably in 5th grade, it'd be my guess. I think my daughter had it in 4th and 5th grade in her work. LCD stands for the least common denominator, or the lowest common denominator, depending on who your textbook author was. And I wrote this, the little denominators, just because I want you to know there's a difference between this denominator. I call this the big denominator, and I call these the little denominators, like they're the smaller ones of all the little fractions inside. Okay? So what we're going to do to clear these complex fractions is we're going to figure out what the LCD is of all the little denominators. We're going to multiply the complex fraction by 1, technically. And the one that we're going to use is the LCD divided by the LCD, because LCD divided by LCD is technically 1. 1 times anything is itself. And it's going to distribute to each term in the numerator and each term in the denominator. It should cancel out the little denominators, and then you'll be able to simplify the problem like you did in section 1. That's what our plan is, so let's give that a try. We are going to do number 6. If you want to do this on a separate sheet of paper, feel free to do so. This is the start of your homework. Step number 1 says that what we're going to do is we're going to look at all the little denominators, and I'm going to circle them. These are all my little denominators. And what I need to do first is I need to figure out what the LCD is, the lowest common denominator. What can all of these go into? The smallest number that they all can go into evenly. And I bet you know what it is. If you do know what it is, tell the person you're sitting next to. I heard lots of wrong answers, and I heard a few right answers. The correct answer is they can all go into 49. Not what can go into them. It's not a GCF. It's a common denominator. The 7 can go into 49, and the 49 can go into 49, but 49 cannot fit into 7 evenly. Does that make sense? Yabby?
Is that like the least common multiple?
Is that what it is, and not the denominator? Least LCM, LCD.
Yeah,
I think they're the same thing, aren't they?
But when using fractions,
Least common multiple. No, I think you're right. It's okay. It's all good. Anyhow, what we're going to do with that number is we're going to take it, and we're going to take this complex fraction, and we're going to be multiplying by the number 1. The way we are going to multiply by the number 1 is the LCD divided by the LCD. 49 divided by 49 is 1. 1 times anything is itself. But what this is going to allow us to do is it's going to allow us to get rid of the complex fractions. How's it going to work? This 49 is going to distribute to the entire, or each term in the numerator and each term in the denominator. This 49 is going to go right here. I'm going to put 49 right there. And the 49 is going to go on the other side of the plus sign. I'm going to put a 49 right there. It also, because we're doing to the top and the bottom, this is going to distribute to the 49 right here. And the 49 is going to distribute over here as well. I'm going to put it in front. So let's just work out what this becomes, equals. 49 times m is 49m. Plus 49 divided by 7, or 7 goes into the 49 we're multiplying by. It goes in 7 times. 1 times 7 is 7. What should happen if we did this right is the little denominator should go away. If they go away, you're doing it correctly. You've picked the right LCD, or common denominator, or LCM as some of you know it. The 49 multiplies the m squared. This 1 goes into there. It doesn't really need to I don't need to bother with it. Minus 49 and 49 goes in one time. You're left with minus 1. And what should happen is, like this one, I have a fraction now, or a rational expression that doesn't have a complex fraction anymore. We've cleared the complex fractions. Now what we're able to do is we can jump to step number 4, which is simplify the problem. All we have left to do is we look for, is there a GCF? I see a GCF of the numerator. In the denominator, I see difference of squares. I see 7m plus 1 times 7m minus 1. And since this is groups of multiplication, they can now reduce. I cannot reduce when there's addition and they're not the same. I can reduce when it's groups of multiplication and the groups are exactly the same thing and there's no plus signs or minus signs in between the groups. This is where we can reduce. 7m goes into 7m plus 1 goes into 7m plus 1 one time. The 7 on top, the 7m minus 1 on bottom, we cannot reduce that because of the minus 1. It's in a relationship with this other thing. We would be breaking order of operations. My final answer for number 6 should be 7 over 7m minus 1.
You know how you can subtract the exponents of, so like 49m and 49m squared?
You cannot, because it's not a group of multiplication.
Oh.
Because of that plus sign and the minus sign. And that goes right along. I have to tell you the most common mistakes that I see. And I'm not going to just use your class. I'm going to go back to my Algebra 2 days when I used to teach Algebra 2. The most common mistakes are when can you reduce and when can't you reduce. And the easiest way for you to start thinking about things is whenever you deal with a problem that looks something like this, you can't reduce the 2 and the 2 because of that plus sign. The plus sign, this bar means it's in a group. You have to do what's in the group first when you're dealing with adding and subtracting. You can't do division, otherwise it doesn't come out to be the same thing that it should. If you tried to reduce here, you can't because of that minus 1. If there was no minus 1, then you could reduce because it's groups of multiplication. That's the biggest difference. When can you? When it's all multiply. When can't you? When there's a plus sign or a minus sign in the problem. Hopefully that clarifies what you can do and what you can't do. And this had nothing to do with the problem, just I was trying to clarify. Last example, number 9. Now, because we had so many issues with what can these all go into? Let me circle all the little denominators. Circle. Circle. What can they all go into with the person you're sitting next to? What can they all go into? The smallest number they all can go into are variable, or both, and why? Discuss, please. I heard. What the heck? Let me tell you, when something goes wrong, I can do a really good job of making it go wrong. There we go. There we go. This is what I was trying to do. There we go. 4x squared. How many of you, raise your hand if you said 4x squared, or you and your partner did? Half of you. Okay. X squared cannot fit into x evenly. X can fit into x squared. That's what it can go into. They have to have a 4 in it. You have to have an x squared in your LCD. So what I'm going to do is I'm going to take this complex fraction and I'm going to multiply by 4x squared over 4x squared. That 4x squared over 4x squared is technically the number 1. 1 times anything is itself. I'm using the multiplicative identity of algebra, or in this one. So this is going to go next to this one in this term in the numerator. I'll put 4x squared right here. This 4x squared is going to go over here, 4x squared there. It distributes to each term. Terms are separated by plus signs and minus signs. It's also going to go to the denominator as well, 4x squared and a 4x squared. What happens is the 4 goes into 4 one time. You're left with x squared times 1. So in this top left piece, you should have an x squared left. Minus x squared goes into x squared one time. You're left with 4 times 1. That's what your numerator is. Your denominator, 2, goes into 4 2 times. You're left with 2x squared. X goes into x squared x times. You're left with 1 times 4x, which is plus 4x. When you multiply by the correct LCD or LCM, whatever you want to call it, this will always get rid of all the little denominators. And now you're in the spot where you can simplify it using what you've done before. Do you see a difference of squares? It factors. The bottom factors using a GCF. 2x. X plus 2. You cannot reduce when it's in this form because it's being subtracted by something. Think of it, it's in a relationship. And we have this one's in a relationship too. And we don't want two people in their own relationships go out with other people in other relationships. Not good advice. But you can do same groups of multiplication. That can go into there one time. And so what we would be left with is x minus 2 over 2x. Can we reduce this x and that x? No, because of that minus sign. If you wanted to, this is going to be my preferred answer right here. The only thing you could do beyond this is you could split it if you wanted to. X over 2x minus 2 over 2x. They're both being divided by 2x. You could split it and get this answer, but which one is better? This one's combined, this one's not. It's like teacher preference. I would have to accept both for full credit on a test. But what I would prefer you to do is just stop right here. If you want to keep going, you can. They are equivalent, but it's up to your teacher, either next year's teacher or the following one, what they want or whatever. But I would accept the first one. Okay? We'll stop your notes right there.